Okay, hello, what's up? My name is Melbay Guy. Actually, my name is Tim, but I love to be called Melbay Guy. Okay, so I'm Melbay Guy, and welcome to my programming class. In today's session, we're gonna look at something small. I don't know whether we're gonna spend so much time on this one, but the goal of this lesson is to be able to point out the elements that were described in session 3. This is session 3. In session 3, we looked at the structure of a program, the elements that makes up a program. So these are the elements that makes up a program. We discussed it into details in the last session, the video. So check it out. In this session, we are gonna look at this current session. We are gonna look at being able to point out, the elements that I talked about, being able to identify them from this program. So this is a program, we already know. If you've been following up to this stage, you know that this is a program. So this program is made up of different elements, lots of elements. We have statements, we have variables, we have expressions, we have decisions, we have functions. So the goal of today's session is to be able to point it, the learner or the student should be able to point that, okay, this part of the program is this element. This part of the program is this element. So this part is a statement, this part is a variable, this part is a condition, this part is a condition, this part is repetition, this part is decision, this part is condition, this part is an expression, and I don't know, any of them. Let's see, we had so many elements. Let me go back to the one. We had so many elements here. We have this one. We have here, we have statement, we have expressions, we have variables, we have data types, and we have all those guys. So the goal of today's session is to be able to point them out, identify them. So although you may not know what this entire program do or what it teaches the computer or the software it creates, you should be able to just tell something small about the program. That's the goal of this session. You don't understand what this program does, but you should be able to look at this. You should be able to look at a random program that you have no idea of what it does, but you should be able to say something about it. Look at the program and say something about it. You should be able to say that, oh, I can see variables. Okay, the programmer created variables here. Oh, I can see statements. I can see a programmer wrote a statement here. Oh, I can see repetitions, yeah. Oh, I can see decisions. You get it? I can see statement. You should be able to tell something like that. That's the first step to being able to write a program or being able to understand a program. So session 4 is all about that. So when we go back to session 3, in the previous sessions we learned about what programming is. Session 1, session 2, we learned about the things we will need to start building programs. In session 3, we learned about the elements that makes up a program. And in session 4, we want to be able to identify these elements in a program. We want to be able to point them. So, okay, this is that. So let's start with statement. What is a statement? This program is made up of a lot of statements. It's made up of a lot of variables, a lot of functions and stuff. So what is a statement? How can you point a statement in this code, in this program? How can you do that? You first have to understand what a statement is. Right now, if I say point a statement in this program, you may not be able, but if you've done programming for a while, you'll be able to point it. But if you're a beginner, you wouldn't be able to point a statement because you may not know what a statement is. What is a statement in programming? In programming, a statement is a single line of instruction that performs a task. Okay, so basically, a single line of instruction, a simple instruction, a mini instruction, a very simple instruction that can stand on its own. and it can instruct the computer to do something. So an instruction that is meaningful, which can tell the computer to do something. And to be able to tell that this is statement, one thing we use to identify a statement is something we call semicolon. This guy, semicolon, semicolon. A statement usually ends with semicolon. So if I tell you to look inside this program and point a statement, you can just look at instructions, because everything is an instruction. We have lots of instructions here. And a series of these instructions is what we call program. And the instructions or the program is made up of different elements. Some are statements, some are variables, some are decisions, and some are blah, blah. So we understood that a statement is a line of instruction. When we say line, mostly we just try and say this. We pick maybe all the text here. We say all these texts are on one line. From here to here, it's on one line. This from here to here is on another line. From here to even here is on another line. That's what we mean by line. Or you can just forget about line and say it's a meaningful, it's a simple, let's say atom. You get it. Atom is the smallest particle of an element that blah, 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 So now, statement, it's a full instruction. You get it? A meaningful instruction. It can tell, it can be small, it can be large, but the important thing is it can tell the computer to do something. The computer understands it. That's what a statement is, a mini instruction. So mostly, a program is made up of a lot of statements, get it? Because every statement has an instruction it gives to the computer. One statement can tell a computer to pop up something. Another statement can tell the computer to close that pop-up and stuff. So we have different types of statements. So how do we identify statements in a program? Assuming I don't know anything about this program, I just saw it on the internet and I want to point out statements in this program. How would I know? So I was saying statement usually ends with semicolon. This is a semicolon, this symbol here. So I can look inside this program and all the instructions that ends with semicolon, I can call them statement. So here I have this guy, int n. It ends with a semicolon. So the word of the is a statement. It's a full instruction. The computer can understand this and perform the action that or the instruction that it is instructing it to, So this guy too is a statement because it ends with a semicolon. When I come here, this guy too is a statement because it ends with a semicolon. So I'm giving you a chance to point statement. Although I can see it, I can feel it. I can feel you're pointing some. Okay, that one is a statement. Yeah, that one too is a statement. Yeah, that one too is a statement. Why are they statement? Because they end with a semicolon. When it's a semicolon, ends with a semicolon. So it's not maybe from here to here that is a statement. It's the whole thing from this here, not from here. The whole thing from this one line up to where the semicolon ends, where there's a semicolon. That's what we call a statement. So it's a full instruction that can tell computer to do something. From here to here is a statement. It's not from here to here, from the whole of this, you get to here, it's a statement. From here to here is a statement because it's a semicolon. So that's the most basic way to be able to point out statement. So you may not understand what the program actually does, but you should be able to look at a program written by masters and tell that, okay, this is statement. I don't know what this program does, but I can tell that this is statement. At least I can see something. If you can say something about a program, that's the first step. It's step by step. We don't just jump and understand what's going on here. It's mind-blowing. If I'm to explain whatever is going on here, some of you just log out and just leave because you can't keep it in the head. It's too much. You get it. So you should be able to tell. Sorry, I think I'm coming. The AC is on, so it's worrying my voice. All right, I'm back. The AC was on, it was drying my voice. I'm sorry. So I would have been coughing for a long time. So now we know what a statement is. So as part of the list, the elements that makes up a program, we have statements. And now we know what a statement is. At least we know a statement ends with a semicolon. So when we just come and we just look at the lines or the instructions or the text that ends with semicolon, then so these are like statements like a sentence, and sentences ends with full stop. So you look at the sentence start from here and it ends with this. Then we can say that okay, this word from double to here is a statement. And a statement is a line of instruction that can tell the computer to perform a task. It is full, it is meaningful. You get it? Assuming I'm writing a statement, I just write double and I remove this part from it. It's not a full statement. It doesn't make sense. Although double makes sense. So imagine removing this guy and keeping this guy. Although this makes sense, this makes sense. This how they have to be written for the computer to understand what you're trying to say. There are times this one can stand on its own, depending on some situation, but this one doesn't stand on its own. You get it? So the main idea is statement is meaningful. It's not part of an instruction. It's a full instruction. It may look small, like this one. This is statement looks very small, but it's a statement. It can tell the computer to do something. You get it? So that's it for statement. So now we can look at this programming point statement. So all we have to check is it ends with semicolon. So this is statement. The whole of this is statement. It ends with semicolon. The whole of this is statement. Ends with semicolon. Okay. This one, from here to here is a statement, ends with semicolon. From here to here is a statement, ends with semicolon. Let's see, from here to here. Some may be statement, but wouldn't end with semicolons. You get it, semicolon, but colons, rather. But, for now, let's stick to where we see semicolons and classify them as statements. So what's the next one? So this section 3 slides, which I'm just borrowing. We have expressions. What are expressions? Basically, to really understand expressions, we have to understand this guy variables. You get it? So expressions are basically something that it's like mathematical expression, a plus b minus 5 or 1 plus 2 plus those expressions. That's how they are. You can evaluate them to get one value, a result. You get it? So the most basic way to be able to identify an expression in a program is they actually have symbols them. If you want to tell that if a particular instruction is an expression, you realize that instruction, one of instruction, makes use of these symbols, logical operators, or makes use of arithmetic operators, or makes use of these guys. You get it? It makes use of these guys. These are relational operators. So when we come inside, we have this guy inside there. We have this guy. Look at here. We have the less than. The less than is part of this guy, relational operators. I think I didn't bring it here, but there's a less than here. So when you see less than or those symbols operators being used with other text and stuff, you can call them expressions because mostly expressions yield one result. They are being calculated or evaluated to produce one result, which are being used for further processing. You get it? But you understand more about expressions later. The goal of this session is not to be able to understand what is going on here or understand what statements are. The goal is to be able to point out a statement. Get it? So you just need some tiny bits of information about what a statement is to be able to point. You know that statement ends with semicolon. It's enough for this session. Get it? And expressions make use of operators. This guy, operators. So I plus 1 is an expression. It's making use of arithmetic operator. You can see it from here. We have arithmetic operator plus. You can see it from here. And also, you should know that a statement can also be an expression. A statement is a full instruction and it ends with a semicolon. That's how we know that it's a statement. But it can be a statement. An instruction can be a statement and can also be an expression. You get it? So all we are trying to say that here you can see maybe I is less than n. It ends with a semicolon, so it's a statement. But I is less than N is also an expression because we have different types of statement. We have this type of statement. This one ends with a semicolon. It looks different. And this one too ends with a semicolon. It looks different. So we have names for this and we have names for that. So something like this, which is a statement because it ends with a semicolon, is still called an expression. You get it? And we have variables as part of the elements that makes up a program. We have variables. So I think we wouldn't go down, 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 down. No, because when I finish describing variables, you're going to be exhausted. You're going to regret ever taking this programming course if I finish explaining what variables are. So today's session, you should be able to at least point statement because statements are many here. You can point plenty, and you should be able to point maybe expressions. Nowadays, you shouldn't be able to point it much, but as time goes on, you should be able to point. So I can point some expression here, I can point some expression here. I saw this one, I can point this one. Even this one can be called expression. You can term this as an expression because it has this equal to, but you see, it's up to you. Mostly the way we understand things is up to you. You can call this expression. You can choose not to call it an expression. Mostly there are no strict rules in this thing. We just put them, all we know is we have to put these things together to build whatever we want to build. So anyhow you want to understand them to put them together, it's all up to you. So I can call this expression. You can choose not to call it an expression. But expressions, one thing you have to know about expressions are you can evaluate them. They are evaluated to produce a result which we use them for other processing. You get it? So in subsequent sessions, we'll be dealing with expressions more so that you understand. So now let's go to variables. Variables, like I said, mind-blowing concept, which is going to exhaust you. So now let's talk about variables. What are variables? I wish you guys were around so we could just discuss it. So we could share your view or your point and move. So what are variables? The concept of variables is the same in mathematics, or let's say it's more like the mathematics concept of variables. We can say, sometimes you hear them say x is equal to 5 or x is 5. They say x is 5. So they will say, evaluate, find the value of x. And someone will get x is 5, x is equal to 5. Someone will get x is equal to 10. Someone will get x is equal to 15. Most of these things are not big deal. If someone gets x is equal to 5, if someone gets x is equal to 15, it's a big deal when it's in exams. After exams, if someone is saying x is 5, someone is saying x is 15, then you know that this is a big deal because someone is wrong. It could be you, it could be the other person. So in mathematics, variables or x, y, z can be any number. Someone can get 15, someone can get 10 for x. That's why we call x variable. A variable is something that can be anything at any time. It can be 10 at this moment, can be 15 at a different moment. So their values are not fixed. That's why we call them variables. In programming, we have the concept of variables inside, but this time, it's not like mathematics. This time, we are dealing with memory. You get it? When it comes to variables, we are dealing with memory. So the computer memory, when you are programming, you'll be working with a lot of memory. You'll be taking memory from the computer and you'll be putting things in and you'll be doing that, you'll be doing that, you'll be doing that. Now, one thing you have to know is the computer memory can contain, or the memory you'll be working with can contain any value at any given point in time. You can first put an initial value of 0 in the memory, and later in your program, you put a different value inside the memory. Or a user can enter something into the memory, and along the program, as the user keeps on using the software, the user will change the value inside the memory. So you realize that the content of a memory varies. Anything can be in a memory at any time. So a memory is what we call variable. You get it? So you can also call the memory variable. So you can say memory or variable because the content varies. 2 can be in a memory at this time. Tomorrow you come and it's a word, and tomorrow, the next day you come, it's 5. You get it? So the computer memory varies. That's why we say the content in the memory varies. That's why we use the term variables. So why do we need a computer memory? When you program, you'll be dealing with memory a lot. And expressions is mostly used with memory. Anywhere you see expression, you realize that memory, there's some memory there. You see here, we have some strange thing called N here. We have some strange thing called I here. You get it? So mostly, expressions are used with memories. And what did I say about memories? I said memories are the same as variables. You get it? So memories, variables, they are the same thing. But we like to call them, programmers like to call it variables rather than memory. You get it? Because the way it's being used inside the program, it is used like mathematics. Here, you see we have, sorry, here we have, I want some simple one for you. Okay, I is equal to 0. Yeah, in mathematics, you can sometimes say, find the value of I. You can say, okay, I is equal to 0. You get it? That's why I use the term variable, because the way we use the memory, it's more like mathematics. We can rename this as X, then it will be X is equal to 0. So that's it. So when you are programming, you'll be using memory in your program. You need it. Why do we need memory? When you want to take input from a user, anytime you want to tell the user to enter something into your program, you would have to reserve a memory space. You have to take memory from the computer to store whatever the user is going to enter. You can't just tell the user to enter something, a value, and not have somewhere to keep that value. That value, the user can't enter something and it will come and hang in your program. That's not how we do it. Anytime you want a user to enter a value, be it number or text, the user's name, the user's age, sorry, the user's age, you should have a memory area, a reserve space there, ready to store whatever the user is going to enter somewhere at the moment, store in at the moment. So our program is going to ask a user to enter a number. We've written a software, and the software is going to ask the user to enter the name. So we know that for a user to be able to enter the name, we need to reserve some memory area in the computer. You get it? So programmers, we have lots of abilities. We can tell the computer to give us memory. Yeah, that's one power for that programmers have. So come on, programming is cool. It's cool, but it's complex. So we can tell a computer to give us memory. And the reason is we want to put something inside. We want to collect data or value or something from the user. And that thing can be the user's name, the user's age. So how do we do that? To tell a computer to give you memory, you need to write an instruction, because everything is instruction. If you want a computer to do this, that, you need to write an instruction. So, and that instruction that tells a computer to give you memory is a statement. So you can see here, there's an example here. And it's N over here. This is statement. And this statement is an instruction. It tells the computer to give you a memory space. You get it? A memory. Why? Because you may want to take something from a user, input from a user, data from a user. So here, just close your eyes and watch this, because here I'm going to use this guy. It's more like Arabic, but don't think about understanding this, forget it. So here, the programmer told the computer to give it a memory. And down here, you see there's a command telling the user to enter something. Whatever the user enters, and you can see N here, you can see N here. It means the programmer is putting whatever the user is entering inside the memory. So the statements, to collect memory from the computer, you need to write a statement. That statement, we have a term for that process, collecting memory from the computer. Most times you hear it, declaration of variables. Declaration of variables, you'll be hearing it more often. To declare a variable, what does it mean? To declare a variable means collect memory from the computer. Another way of saying it. So if someone asks you, you're a programmer, and someone asks you, declare a variable, all the person is trying to say that is, what the person is trying to say is, collect memory from the computer. Declare variable, collect memory from the computer. To collect memory from the computer, you need to write an instruction, you need to write a statement. And that statement the statement or the instruction that collects memory from the computer has two main parts. One part is here. You can see there's one part and there's another part here, and there's this semicolon showing that the whole thing is a statement. So the instruction is made up of two parts. One part, this part, tells the computer where it should take the memory from, because we assume that there are several sections of the computer memory. We have part for storing numbers, we have part for storing words, we have part for storing characters and stuff. You get it? So to tell the computer to give you memory, you need to tell the computer where it should take the memory from. Should it take it from the number section? Should it take it from the word section, or what? So this part of this statement, this is a statement instruction. So this part will tell the computer that, oh, take the memory from the number section. Int means integer. It's a short form for integer. Integer is number. So you're telling the computer that, oh, I want a memory. This will tell the computer, I want a memory. But take the memory from the integer section of the memory. And this part is the name that you want to give to the memory. Get it? So to collect memory from the computer, you need to specify two things. The data that what you'll be storing there, where it should take the memory from, the type of data you'll be storing there. So it's mostly called data type, the type of data you'll be storing or collecting, you'll be collecting from the user. And we have this part, which is the name you want to give to the memory, because you realize that you'll be collecting so many memory from the computer for different reasons. So all those memory must be labeled or must be given a name. So here the programmer chose to give the memory the name N, so that anywhere in the program the user can refer to that memory. So assume I've taken 3 memory from the computer, it is the name that will tell which memory I'm trying to interact with. You get it? So you see, this is the statement. It's called variable declaration. I've already told you variable declaration means collecting memory from the computer. To collect memory from the computer, you have to write a statement or an instruction. That instruction is made up of two parts. One part will tell the computer the type of data you will be storing in the memory or where it should take the memory from. And one part will tell the computer the name you want to give to the memory. And we end with a semicolon because it's a statement, it's a full instruction. So here, when we pass this, so you can see here, there's another one here, double. You see, inside the memory too, we have a place for storing. When it comes to numbers, we have a place for storing integer numbers, and we have a place for storing decimal numbers. So here too, you have to specify, the person is specifying that, oh, I want memory from this guy section, the decimal section, decimal memory section, because I'll be storing decimal numbers. This one is saying I want memory. And this is the name for this guy. This one too is another type of taking memory from the computer, but we are not discussing this one here. You get it? But when you see here, you can see that this is still variable declaration. This variable declaration. This one is bigger than today's, what the guy is doing here is bigger than today's session. But don't worry about it, we'll get there. So here we know this. So let's take this guy off. Let's use the simple one. So int N. So we know there's a variable declaration. So if I say declare variable A, it means all I'm trying to say is collect memory from the computer and name that memory A. Declare variable N, it means collect memory from the computer and name that variable N. Once you collect memory from the computer, you can do two things. You can read from the memory or write to the memory. To read from a memory means put something in, check what is inside the memory, check the contents of the memory. To write to a memory means put something inside the memory. You get it? So when you take memory from the computer, so here I've taken a memory from the computer with this instruction. You won't see it because everything here is in the form of text. But when it's given to the computer, a memory will be collected and reserved for you. Get it? When you get a practical aspect, you see it. So anytime you see here, anywhere you see N, you can see N here, you can see N here, you can see N here. So the programmer is interacting with the memory at so many areas in the program. You get it? So this first, the memory, this is a memory. The name of the memory is N. Over here, this instruction is saying that a user should enter, the computer should take input from a user and should store the data inside what's the memory N. You get it? And here too, they are working with the N, manipulating. So This session is not about understanding what variable is. It's not about understanding what statement is. It's just about being able to point a statement or being able to point a variable and being able to point expressions. Like being able to point these guys, the elements that makes up a program. In subsequent sessions, we'll talk about variables more and we'll talk about statements. We'll deal with it. So that's it for this session. I don't want to go deep. There are so many elements here. And you see the variables is even too much for you to process. You get it? And there's a practical aspect that will explain it better. But all you have to do is, right now, all you need is to understand that variables are memory. When you say variable, it's just memory. It's another term for memory. And we need a computer memory anytime we want to take input or data from a user. You get it? Why do we take input or data from a user? We need to process them. Some of our softwares require us to take input from user, like a calculator software. It takes users' numbers and perform operations on them. You get it? So for you to be able to take the user's input, you need to create memory space. You need to collect memory from the computer to hold individual values that the user will be entering. After you've trapped them or collected them, then you perform operations using the other elements over here. So that's it for this session. You should be able to just point out, okay, this is statement, this is statement, not this. This one has a different name. This one has a different name though. It's called comments. We have comments. So the elements, they are different. We have so many elements, but you see them as one program, but there are different elements working together. So before I said the statement ends with a semicolon. So anywhere you see a semicolon, you can say this is statement, this ends with a semicolon. So it's a statement. Okay, this one is a semicolon here. So all this is statement. And we have variables too here. We can see it's n. You see, we have this variable here, n, and it's a variable. It's here to a variable. It's a variable n. You get it? So that's it. So the goal of this session is to be able to point some, not all, because to be able to point all requires so much, hard work and listening. So I don't want it to be too much. So at least we can point statements, we can point variables, we can point expressions. You shouldn't be perfect in pointing them because you don't know much about them now. You just have to take your time. With time, you'll be able to point the rest. Okay. So in the next session, so this session is the end for this week's session. You get it? So this class is basically a private class for some students in the University of Cape Coast. I'm just having it for them. But I decided to share it for some of you guys to, be able to learn something small about the foundation of programming, gain a bit, some foundation of programming, to be able to learn elsewhere or, journey, you get it, to get something and use along your way. That's why I shared it here. But it's a private tutorial, which I meet my students like 4 times a week. Yeah, some of my students are on campus. That's why I did this video. So I meet my students 4 times a week, and I charge them, but I don't charge them that much. It's too small, it's very small amounts. Let's say I don't want to. Okay, so if you are in Ghana, what are the amounts I charge them is like 10 cedis a week. I meet them like 4 times, 2 hours, 2 hours per each. You get it? So if I meet you, I have to meet you 4 times a week, and each meeting is 2 hours, and it's just 10 cedis a week. It's not much. If you're in Ghana, it's 10 cedis a week. If you are in different country, it's very low. It's very low. You get it? And I'm not doing it for the money because the money is it's not enough for this type of lessons. But you have to help people. And the money is the motivation that helps me to continue on this. Okay. But if you guys want this to be free, then you have to donate something. If you donate something, then I can make them free because I need to get enough resources to be able to put these things together. So you can donate anything you have, something small to support the class so that I can release them for free, because it will be good to release them for free. There's no point in charging people to learn this. It's a skill. We need to give it to the youth. They need to. So if you can't support, you can just donate, you can just assist. So that I'll make it free. Okay? But it's a private class. So the work from session 1 to session 4 is for this week. Yeah, it's this week's session. So next week, I have the week 2 session. So I'll be releasing them. I'm already done with those sessions. These are just videos of repeating what I did. I made them and taught them. So these are just, so I just use one day to just put all this together, but mostly it should come weekly. Get it? So this is the end of week 1 session. Your journey in programming class with Melbay Guy. So that's it. So if you want this to be free, like I said, those who can support you support. Just donate something, help with the resources. I have to feel good. If I feel good, I'll get more resources and bring, get it. But for now, it's a private class. But the goal of releasing, the reason why I released it here, I said it, to help, to give some of you guys foundation, even if you can't afford it. It's very low, the cost is very low, but even if you can't afford it, you still need this foundation, you need the foundation to go, you get it? It's a foundation you need to be able to continue learning from different masters and learning from everywhere. That's it. Okay, so I'll be releasing the next session. In the next session, we are going to look at, which is week 2, session 1. We've already talked about the elements that makes up a program. We have statement, we have expression. In the next session, in the next week session, the week 2 session, session 1, we are going to talk about statements. We are going to learn about we are going to learn how to construct a statement, how to pass the statement to the computer, and see how the computer will respond, or how the computer will carry out that instruction. So session 1 for week 2 is all about statements. You're just going to practice statements. So it's more of practicals for session 2. And you don't need so much. You don't need so much. Okay. So this programming class, let's just say that I'm teaching the programming idea, the general programming idea, so that you can do any programming language you want, because in every programming language, you still have to combine this. We have all these concepts there, which you have to combine to be able to build the software you want or teach the computer anything you want. So you can pick Python, you can pick Java, but you still deal with statement, expression, variables, because these are what we use. You get it? These are what we use. So right now, our focus is on how to combine these things to build the software. We are not looking at the type of language we are going to use. We are just going generally, in general. So after we are done and we've understood how to combine some of this and we've understood this concept, then we'll pick a particular programming language and implement them. But week 2, session 1 is practical. So we're going to learn about statements. Statement. How do you construct a statement? What is a statement? How do you construct it? How do you pass it to the computer? And how does the computer respond to that instruction? That's all for this session. Thank you for joining this class. Love you guys.